guys, good day. My name is Lynette
And I am April,
and we are the students from
University of Science and Technology of Southern Philippines or USTP.
taking a Bachelor of Science in Information Technology. So, since that mathematics is one of the most common subjects that students tend to have a problem about, we're going to have a tutorial today that may help you guys better understand a certain topic in math.
And the topic would be
Right,
how to solve rational equations.
Hi there once again. Before proceeding to the tutorial proper, it is important for us to know first the definition of a rational equation. So, rational equations are equations with rational expressions, meaning that the equation should have at least one fraction with the numerator or denominator or both that are polynomials, where p and q are real numbers and q should not be equal to 0, and these fractions may be on one or both sides of the equation. So, let's say if we have negative x over x plus 3 minus x over x minus 3 is equal to negative 4 over x squared minus 9 minus 1 over x plus 3. Do you guys consider this as a rational equation? Can you see rational expressions being involved in this equation? Right, of course. In fact, we have two rational expressions here. Negative x over x plus 3 minus x over x minus 3 and negative 4 over x squared minus 9 minus 1 over x plus 3. So since we have rational expressions in this equation, then we can say that the given equation is a rational one. Now, let's proceed to the solving aspect. April?
Hi guys! So, how are we going to solve rational equations? Just like the other types of equation, rational equation involves series of steps to do so. But it's simple. We just need to follow 4 steps. First, eliminate all fractions. Second, simplify. Third, solve the simplified equation. Fourth, check each solution. Now, let's solve a couple together. The given rational equation is x plus 3 over x minus 2 is equal to x plus 4 over x minus 5. Hey, Lynette! I said, let's solve it together.
There's no need to fret, guys, because our math tutorial officially starts here. The given equation is x plus 3 over x minus 2 is equal to x plus 4 over x minus 5. So, according to the steps that my partner had mentioned earlier, the first step to solve this equation is to eliminate all the fractions. How? We have a choice of 2 ways to eliminate such. Option 1 is to multiply the entire problem by the least common denominator, or LCD. And option 2 is to cross-multiply. Option 1 will work for any problem, but we can only cross-multiply if there's one fraction equal to one fraction. That is, if the fractions are proportional. So, in solving rational equations, all fractions should disappear in the first step. Back again to the given equation, both ways are applicable in eliminating the denominator. But since the fractions used are proportional, we'll just simply cross-multiply both, which results to x plus 3 times x minus 5 is equal to x plus 4 times x minus 2. The next thing we need to do is to simplify the resulting equation. In order to do this, we need to distribute all the values using FOIL method. And we get x squared minus 5x plus 3x minus 15 is equal to x squared minus 2x plus 4x minus 8. Then we combine like terms. Negative 5x plus 3x is equal to negative 2x. And negative 2x plus 4x is equal to positive 2x. So our new equation is x squared minus 2x minus 15 is equal to x squared plus 2x minus 8. The third step, which is solving for the simplified equation, follows. We need to get the x on one side and the other numbers on the other side of the equation. And based from the rule when we're going to transpose, we have to change the signs to its opposite. In this case, x squared will be cancelled out. So our new equation will be negative 2x minus 2x is equal to negative 8 plus 15. Then solve. Negative 2x minus 2x is equal to negative 4x. And negative 8 plus 15 is 7. Then we're going to divide both sides by negative 4 to eliminate the coefficient of x. So negative 4x over negative 4 is equal to 7 over negative 4. Then we'll get the answer of x is equal to negative 7 over 4. So this will be our solution set in the equation of x plus 3 over x minus 2 is equal to x plus 4 over x minus 5. Normally, once we get the value of x, the solving process is done. But in this case, it's not, since we have an extra step and the final process in solving the given equation. In rational equations, sometimes our solution set looks good, but they carry a virus. That is, they won't work in the equation. These are called extraneous solution. That's the reason why we need to check our final answers if it satisfies the whole equation. And to do that, we just simply substitute the value of x to the equation, which is x plus 3 over x minus 2 is equal to x plus 4 over x minus 5. So, since that we're solving complex fractions here, we have to bear in mind the denominators of each expression present in the equation. This equation involves addition and subtraction, so we have to be mindful that they need to have the same denominators. If not, then we have to find the LCD so that we can proceed with the operational process. In negative 7 over 4 plus 3 over negative 7 over 4 minus 2 is equal to negative 7 over 4 plus 4 over negative 7 over 4 minus 5. This clearly shows the difference of the denominators present in each expression. Our goal here is to have them with the same denominators using their respective LCDs. We can either multiply the number needed for each term to get the LCD in both numerator and denominator, or simply get the LCD and divide it to the denominators, and the results will be multiplied to the numerators. In this equation, the entire expression have the same LCD, which is 4. So we have, which results to negative 7 plus 12 over 4 over negative 7 minus 8 over 4 is equal to negative 7 plus 16 over 4 over negative 7 minus 20 over 4. Now, we can finally proceed to the operations required in both numerators and denominators. So we have negative 7 plus 12 is equal to 5, then just copy the denominator, which is 4, and negative 7 minus 8 is equal to negative 15 over 4. We just need to do the same thing to the other side of the equation. So negative 7 plus 16 is equal to 9 over 4, and negative 7 minus 20 is negative 27 over 4. So, now that we're done performing the operations needed, the next step is to solve the division aspect and see if it's really the same. But since this is division, we are going to multiply the numerator with a reciprocal of its denominator. So, we cancel out 4 and 4 in both sides of the equation, which results to negative 5 over 15 and negative 9 over 27. Next step is to convert these terms into its lowest term. The left side of the equation will be divided by 5 over 5, and the right side will be divided by 9 over 9. And we get the answer of negative 1/3 is equal to negative 1/3. So, since that we arrive at the same answer, then we can say that negative 7 over 4 is really the solution set of x plus 3 over x plus 2 is equal to x plus 4 over x minus 5.
This time, we're going to solve a more complicated equation. So, our equation will be the one that was set as an example in the definition of rational equation, which is negative x over x plus 3 minus x over x minus 3 is equal to negative 4 over x squared minus 9 minus 1 over x plus 3. Since this is a rational expression, the first step that we are going to do in order to get the value of x is to multiply the whole equation with its LCD in order to eliminate the denominators. But before we get the LCD, it is very important to check if there is a factorable term in the equation. In this case, we have x squared minus 9, which can be factored to have x plus 3 and x minus 3. In this equation, we can see that LCD is x plus 3 times x minus 3, so we are going to multiply the equation with x plus 3 times x minus 3. Now, we can eliminate the denominator by cancellation, and the result will be x minus 3 times negative x minus x plus 3 times x is equal to negative 4 minus x minus 3 times 1. The next step is to perform arithmetic operations with the rule of order of operation, which multiplication and division first before addition and subtraction. We are going to perform multiplication. Since we are multiplying polynomials, we have to use distribution if there is a need to. In this case, we have to use distribution. In the first term, we have to distribute negative x to x minus 3 in order to get negative x squared plus 3x. In the second term, we need to distribute x to x plus 3 in order to get x squared plus 3x. And in the last term, we need to distribute negative 4 to x minus 3, and the result will be negative x squared plus 3x minus x squared minus 3x is equal to negative 4 minus x plus 3. So, we have already multiplied terms that we can multiply. The next step would be combining like terms, or simply performing addition and subtraction. We can rearrange the equation to make it easier. Negative x squared minus x squared plus 3x minus 3x is equal to negative 4 plus 3 minus x. 3x and minus 3x will be cancelled out, and the remaining would be negative 2x squared. And negative 4 plus 3 is equal to negative 1, and the remaining would be negative x minus 1. And the result is negative 2 x squared is equal to negative x minus 1. We have already combined terms, and now we are going to transform the equation to the standard form, which is ax squared plus bx plus c is equal to 0. Please note that we need to change the sign of the term that we are going to transfer. We are going to transfer negative x and negative 1 to the left side, and it will become positive x and positive 1. And the result would be negative 2x squared plus x plus 1. We already have the standard form. Now we can proceed by using quadratic formula, which is x is equal to negative b positive negative square root of b squared minus 4ac over 2a. In this equation, negative 2x squared plus x plus 1 is equal to 0. A is equal to negative 2, b is equal to 1, and c is equal to 1. We are going to substitute the values of the variables to the formula. Then x is equal to negative 1 positive negative square root of 1 squared minus 4 times negative 2 times 1 over 2 times negative 2. Next, negative 1 positive negative square root of 1 squared is equal to 1, and negative 4 times negative 2 is equal to 8 over negative 4. And the next is negative 1 positive negative square root of, we add 1 plus 8, and it will become square root of 9 over negative 4. Since square root of 9 is a perfect square, then it will become 3. So the equation would be negative 1 positive negative 3 over negative 4. The x sub 1 would be equal to negative 1 plus 3 over negative 4, and negative 1 plus 3 is equal to 2 over negative 4, or negative 1 half. The x sub 2 would be equal to negative 1 minus 3 over negative 4, then negative 1 minus 3 is equal to negative 4 over negative 4, or equal to 1. In order to check if our answer is a solution set of the equation, we just need to substitute the value of x sub 1, which is negative 1 half, to the x's in the given equation, which is negative x over x plus 3 minus x over x minus 3 is equal to negative 4 over x squared minus 9 minus 1 over x plus 3. After substituting, the equation will become negative times negative 1 half over negative 1 half plus 3 minus negative 1 half over negative 1 half minus 3 is equal to negative 4 over negative 1 half squared minus 9 minus 1 over negative 1 half plus 3. The next thing that we need to do is to find the LCD of the denominator in each term. The LCD of the denominator in the first term is 2, so it will become negative 1 plus 6 over 2. In the second term, the LCD is 2, so it will become negative 1 minus 6 over 2. In the third term, the LCD is 4, so it will become 1 minus 36 over 4. And in the last term, the LCD is 2, so it will become negative 1 plus 6 over 2. The next step is to subtract or add all that can be subtracted or be added in the denominator. In the first term, we add 6 from negative 1, and it will become 5 over 2. In the second term, we subtract 6 from negative 1, and it will become negative 7 over 2. In the third term, we subtract 36 from 1, and it will become negative 35 over 4. And in the last term, we add 6 from 1 and it will become 5 over 2. The next step is to reciprocate, and the equation will become 1/2 times 2 over 5 minus negative 1/2 times negative 2 over 7 is equal to negative 4 times negative 4 over 35 minus 1 times 2 over 5. In the first term, the 2 can be cancelled out and it will become 1 over 5. In the second term, the negative sign and 2 can be cancelled out and it will become 1 over 7. In the third term, we multiply negative 4 and negative 4 and it will become 16 over 35. And in the last term, we multiply 1 and 2 and it will become 2 over 5. And the equation will become 1 over 5 minus 1 over 7 is equal to 16 over 35 minus 2 over 5. The next step is to find the LCD. The LCD in the left side is 35 and it will become 7 minus 5 over 35. The LCD in the right side is 35 also and it will become 16 minus 14 over 35. In the left side, we will subtract 5 from 7 and it will become 2 over 35. In the right side, we will subtract 14 from 16 and it will become 2 over 35. Since the final answer in both sides are equal, therefore, negative 1/2 is a solution set. In order to check if the answer is a solution set, we need to substitute the value of x sub 2, which is equal to 1, to our equation, which is negative x over x plus 3 minus x over x minus 3 is equal to negative 4 over x minus 1 over x plus 3, and it will become negative 1 over 1 plus 3 minus 1 over 1 minus 3 is equal to negative 4 over 1 squared minus 9 minus 1 over 1 plus 3. Then, negative 1 over 1 plus 3 will become negative 1/4 because we add 1 and 3. Then, negative 1 over 1 minus 3 will become negative 1 over negative 2 because we subtract 3 from 1. Then, negative 4 over 1 minus 9 will become negative 4 over negative 8 because we subtract 9 from 1. Then, negative 1 over 1 plus 3 will become negative 1/4 because we add 1 and 3. The equation will become negative 1/4 plus 1/2 is equal to 1/2 minus 1/4. Then, the next step is to find the LCD, and the LCD in both sides is 4. Then the equation will become negative 1 plus 2 over 4 is equal to 2 minus 1 over 4. We need to subtract 1 and 2 and it will become 1/4. Since both sides of the equation is 1/4, then x sub 2 is equal to 1 is a solution set. Now, try answering these examples. Example number 1. 32 over x squared plus 3x plus 2 minus 3 is equal to x minus 3 over x plus 1. Example number 2. 3y over 3y plus 4 plus 2 over 5 is equal to y over 3y minus 4.